So in 4.2.3, we're going to talk about another type of experimental design, and it's kind of going to be analogous to a type of sampling. But I want to be really clear that when you use language to describe experiments versus using language to describe sampling, you have to be specific in that language because they're separate things. So in sampling, we have like a simple random sample, right? And that's where every individual in the population is equally likely to be selected into the sample. And then you have something called stratification, right? And that's where you first decide on subsets of the population that you're going to select simple random samples from so that you make sure that there's representation from those subsets in your sample, right? So there are analogs in experimental design. So kind of the analog of a simple random sample is a completely randomized design. And that's where you just take your subjects and you immediately assign them randomly to their treatments, right? And then today we're going to talk about blocking. And we'll use blocking when there's an expectation that certain subsets of our population that we're experimenting on are going to react differently to the treatment. So let's say you're testing a drug, and because men and women's bodies are biologically different. I hope I'm not breaking anything new to you, but different hormones, they may react differently to that drug, right? And so if you suspect that, then maybe what you want to do is separate out your male and female subjects first, and then with your male subjects, you'll randomly assign half of them to the treatment group, half of them to the control group, and do the same with your female subjects because you suspect they'll react differently. So you don't want basically the biological differences muddying up the comparison that you're trying to figure out in terms of the effect of the drug. Does that make sense? So that's kind of blocking is kind of an analog of stratification. But I want to be really clear if you're asked to describe an experiment and you say something like use a stratified experiment, that doesn't make sense and you'll lose credit on the AP exam. Okay, so you have to use the language of experiment when you're talking about an experiment. So you would say a blocked experiment and then use the language of sampling when you're talking about sampling. So stratification when you're talking about sampling. All right. But as I kind of alluded to, blocking is basically the analog of stratified sampling. Okay. Okay. So blocking is grouping experimental units that are known before the experiment to be similar in some way that is expected to affect the response to treatments. All right, and in a randomized block design, random assignment to treatment is carried out within each block. So basically what you're doing is you recognize that, you know, the experimental units are similar in some way that may affect response to treatment. So you separate them into groups that are similar in that way, and then you carry out the entire experiment within each group, right? So each block gets a treatment and a control. And kind of the most extreme version of a block is a matched pairs design. And that's where each experimental unit constitutes a block. So an example of that would be like the caffeine experiment we talked about at the beginning of this unit, where we were going to see what the effect of caffeine was. And so on your heart rate, so what you did was take your pulse before having caffeine, and then I give you some caffeine. We all decided it would be most effective if we injected the caffeine, and then I'm just kidding. We decided that was extremely dangerous. That was Katie's idea. And then and then you took your pulse rate after having the treatment of caffeine, right? In that case, you are your own block, basically, right? Because you're receiving the control, which is basically you're taking your own heart rate before treatment, and then you're receiving the treatment. You're injecting caffeine and then taking your heart rate after. So you are your own block, and that's what a matched pairs design would be. And we'll do an example of that. But first, let's do some statistical research on microwave popcorn. All right, a popcorn lover wants to know if it's better to use the popcorn button on her microwave or use the amount of time recorded or recommended rather on the bag of popcorn. To measure how well each method works, she will count the number of unpopped kernels remaining after popping. To obtain the experimental units, she goes to the store and buys 10 bags of 4 different varieties of microwave popcorn: butter, cheese, natural, and kettle corn, for a total of 40 bags. All right, explain why a randomized block design might be preferable to a completely randomized design. So in a completely randomized design, we take all 40 bags, put them in a giant trash bag, mix them up, randomly select 20. Those go to the popcorn button. The other 20 will use the recommended amount of time on the bag. But why? Can any of you help me out? Why would we probably want to use a block design here? Go ahead, Riley.
Maybe like based on type of popcorn, it'll pop differently, or
Good.
like that'll how long it's.
I agree. So we suspect, right? So flavor may impact popping time. Hot take, popcorn is not good. Don't like it. Gets stuck in your teeth, dry. Not a good snack. My son loves it, and he gets it. My wife always buys that Smart Pop, that like just bagged popcorn. It gets everywhere. All over the couch. Drives me insane. He just heard me.
You should be ashamed of yourself.
All right. So we're going to outline a randomized block design then. So we'll take our, I don't know if I have enough room. I'm going to have to All right, I'm going to clear this out so that I have more room. I'll bring it back though. All right, so I'm going to choose to do the design diagram rather than the just write it out verbally. So we're going to start with all right, so we start with our 40 bags of popcorn, right? And the first thing we do is block. So we separate them into, what was it? What were the flavors? 10 cheese, 10, damn it. Oh, hold on, I have my book here. So if I bring it back, then I'm gonna erase my precious work. Oh, here it is. What do we got? Oh, butter, cheese, natural, and category. So 10 butter, 10 natural. Also, if you're gonna eat popcorn, how much do you hate yourself to have the world's worst snack and then just have natural flavor? It's just like eating packing peanuts. Natural flavor, Aaron? Popcorn? That doesn't. 10 kettle. Okay. So then within each, we're going to do a random assignment. I don't know why I thought I could do this on the iPad. When this just makes me remember when we do this in person, I like fill my whole board with this. All right, and so we have to do each random assignment. We have to do 2 treatments, right? So we have to do, and I'm actually going to make a key up here. Treatment 1, we'll do popcorn button. And T2, we'll call recommended. Are there 2 M's in recommend? Yeah? Okay. Recommended time. All right, so then we'll go, right? So we'll go 5T1, 5T2, and we'll do that for each. But also, do you guys use those buttons? Do microwaves even have those buttons anymore? Do you use anything other than just putting the time in? You don't put, yeah, you don't put like a plate of food in and then press the dinner button or whatever, do you? That seems insane to me. All right. All right, and so then I'm going to describe off to the side again what our measurement is. So I'll say measure. Actually, let's create a key because let's do capital M, and that means measure unpopped kernels. All right, so I'll do M, M. And to be honest with you, this one might have been shorter if you didn't do the design diagram and you did just describe it verbally, but I have a hard time with handwriting, so this is easier for me. And then you're going to compare within each. Now, I want to be very clear about something here. You don't compare between blocks. The whole reason we separated them into blocks was because we thought there would be a different effect of the treatment with each group, right? So it wouldn't make sense to compare between blocks because we thought the effect would be different. So the language you have to use at the very end here, oops, you're going to go all of them down here and you're going to say combine results. So not compare between blocks, you combine at the end. All right, and now let's describe our random assignment. So I'm going to say after separating, actually I should probably use the language of experiments. After blocking by flavor, place each flavor, and I'll say, just to be clear, 10 bags. In a bag. Mix thoroughly. Select 5 for T1. The 5 that remain are assigned T2. Whew. All right. All right, very good. And so this is just reiterating what I said before. So a block design is kind of an analog of a stratified sample. But remember that blocking is the language of experimentation and stratification is the language of sampling. And it can be a bit confusing because, yes, we need to sample to experiment, right? So we take a sample and that sample represents oftentimes our experimental units, but they are separate things within statistics. All right, and so we already talked about this, but going back to the caffeine experiment that I discussed, where we're trying to see the effect of caffeine about on your heart rate. So we're gonna measure, each person is their own block. You're gonna measure your heart rate before injecting caffeine and after injecting caffeine. And so a matched pairs design is probably best, like I said. And that's where each individual is their own block. But if you were going to do an experimental design where you didn't use matched pairs, you could block for things like mass, like body weight. If you wanted to, you could do, I don't know, general, like caffeine consumption. So you could survey people on, is the I before the E in caffeine? Oh, I guess I could look at that. No, it's after the E. So you could survey them about their caffeine consumption before and create blocks based on that, right? What else? What else might affect heart rate with caffeine consumption? There could be a ton of things, right? Gender, or again, you could survey them about anxiety levels. Caffeine like really throws me off. All right, so let's say I decided to block by caffeine consumption. And I identified people as regular coffee drinkers, or we could say heavy coffee drinkers, moderate coffee drinkers, and non coffee drinkers. Then let's say I had 30 subjects. And I separated them into 10 heavy drinkers, 10 moderate drinkers, 10 non drinkers. I would then do T1, T2, T1, T2, T1, T2, right? Oh, measure, 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 and I'm going to describe what those are and compare. And then we'll go ahead and combine results. All right, so in this case, I would say that T1 is inject caffeine. T2, I would say inject placebo, right? So saline. Because you would want to take into account the placebo effect in that case. And then I would say my measurement is just measure pulse rate. All right, we already talked about how you could use a matched pairs design. So matched pairs would be each subject is their own block. And receives both treatment. So if we were doing this the way I described, if we were literally injecting caffeine, right, what we would have to do then is, for a matched pairs design, everybody would have to receive treatments on different days, right? And what you would need to do is randomize treatment. So it's not like everybody gets the caffeine injection on day 1 and then the saline injection on day 2. You would have to actually randomize the order for every individual person because the day could possibly influence the effect, right? Like if it's day 1 and there's like a huge thunderstorm, that could affect their pulse rate or whatever. So you would want to make sure you randomize treatment order. For each subject. Okay, does that make sense? Go ahead and give me a green check if you're good with that slide. If you have questions, just go ahead and ask. Cool. All right, so scope of inference. The two factors that determine the scope of inference. So this is what can you generalize your results to? Are sampling and assignment of treatments. And again, I'll just note that what scope of inference mean is where can I generalize my results? All right, so we're just going to look at a grid and we'll talk about the scope of inference sort of for each quadrant in the grid. So the columns are were individuals randomly assigned to groups, and the rows are were they randomly selected from a population. So if they were both randomly selected from a population, so you have a good random sample, and you were able to randomly assign that sample to treatment, then yes, you can make inferences about the greater population. And yes, you can also make inference about cause and effect, meaning you can determine that the treatment causes an effect in the response. All right, let's go to the right. Yes, we selected a random sample, but no, we did not randomly assign to groups. Yes, you can make inferences about the population, but basically, since you're not doing a random assignment, this really isn't an experiment. It's more of an observational study. So no, you can't determine cause and effect. You can determine an association between the explanatory and response variable, but not necessarily cause and effect. To determine cause and effect, you need a controlled, randomized experiment. All right, were individuals randomly selected from a population? Let's say no, rather. And yes, we were able to randomly assign treatment. No, you generally can't make inferences about the population there, but yes, you can make inferences about cause and effect. Most experiments are actually in this category because you can't ethically randomly select a group of subjects from the greater population, right? You can't go, okay, I'm going to go into the census data and randomly select a group of people and force them into my experiment, right? They have to volunteer into experiments. So it's not a true random sample. This did get me thinking about the vaccine and wondering if it was a voluntary response sample. I think it, I'll look into it. But because it literally needs to be, we're trying to create a vaccine for the entire world's population, we need to be able to generalize those results, right? So they want a true random sample for that. So I'm wondering if they did select a sample from like the census data and then just contact those people. And obviously those people still had to volunteer in, but that's not voluntary response. That's a random sample then because they chose the people beforehand. And if the people decided not to get the vaccine, that would just be that'd be considered non-response, right? Um, I'll look into that. I wonder how they did that. All right, and last quadrant is inferences, not randomly selected from a population and also not randomly assigned to groups. So this is again an observational study, but it's one in which really it's a bad observational study. You can't make inferences about the population and you can't make inferences about cause and effect. So in each of these, let me read the prompt first. So many students insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. And here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the study. And so for each design, suppose that the mean GPA for students who listened to music while studying was significantly lower than the mean GPA of students who didn't listen to music while studying. What can we conclude for each design? All right. So I will make a note next to each of these what we conclude. So for the first design, we get all the students in our AP statistics class to participate in the study, ask them whether or not they study with music, and divide them into 2 groups based on their answer to this question. So this is not a random sample because it's a convenient sample, right? We're just using you guys, my AP statistics class. And it's also not random assignment, right? I'm surveying you on whether or not you listen to music. So really I can't conclude I can't really make any inference here, so I'm just going to say no inference. All right, now if I select a random sample of my school to participate in the study, and then I divide them into 2 groups as in design 1. So now I am taking a random sample. So let's see, we would be in this quadrant. So I am taking a random sample, but I am not assigning treatments. So I can determine association, but not cause and effect. So I could say that music is associated with GPA. All right, get all the students in your AP statistics class to participate in a study. Randomly assign half the students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. So back here, right, I'm now in this quadrant. So I can determine cause and effect, but I can't really generalize this to a greater population because it's not a random sample. So what I would say is that music causes lower grades with students in my AP class. So again, can't really generalize to the greater population because it's not a random sample, but I can determine cause and effect for my students and students that are very, very similar to my students. And the last one, select a random sample of students from your school participate in the study and then do random assignment. And so for that one, I could say that music causes lower grades for students at my school. Because that's the sample, that's the sample, the representative sample of my population, specifically students at my school.